In this video, we will talk about how to find the modular multiplicative inverse of a number. So here's the formal definition. We say that the modular multiplicative inverse of an integer a is an integer x such that a times x is congruent to 1 mod m. Now, a way to say that in simpler terms is it's just the integer x such that when we do a times x divided by m, we have a remainder of 1. Now, it's worth noting that the modular multiplicative inverse only exists when the greatest common divisor between a and m is equal to 1. And here's the trick that we can actually use to find the modular multiplicative inverse. Just find which factor of m times k plus 1 is divisible by a, where k is just the integers 1, 2, 3, and so on. So let's take a look at a few examples of how to actually find the modular multiplicative inverse. This first example says, find the modular multiplicative inverse of 4 mod 17. So this 4 right here, this will be our a. This 17 will be our m. So remember, we first have to check, does the modular multiplicative inverse even exist? And it only exists if the greatest common divisor between a and m is equal to 1. So the greatest common divisor between 4 and 17 is indeed equal to 1. Another way of saying that is that 4 and 17 don't share any factors, so their greatest common divisor must just be equal to 1. So we know that the modular multiplicative inverse does exist. So to find it, we're going to use this trick right here, where we just find which factor of m times k plus 1 is divisible by a. And we'll start with a value of k is equal to 1. So if we use k is equal to 1, we'll plug in that into this formula. Remember, m is 17 in this example. So that would be 17 times 1 plus 1. So this is 17 plus 1, that's 18. So is 18 divisible by a? A in this case is 4. Is 18 divisible by 4? No. So we'll say not divisible by 4, so then we'll move on to the next value of k. Let's try a k value of 2. So if we plug in a k value of 2, we end up with 35, which is also not divisible by 4. Now let's try a k value of 3. So this produces a value of 52, which is divisible by 4. So our final answer for the modular multiplicative inverse is going to be 52 divided by 4, and that turns out to be 13. So the modular multiplicative inverse of 4 mod 17 is 13. So to make sure that we got the right answer, we should be able to do a times x divided by m, and our remainder should be 1. So remember, a is 4, x is 13, what we just found, and then we're dividing that by m, which is 17. So 4 times 13, that's 52. And 52 divided by 17, that turns out to be 3 with a remainder of 1. So we do get this remainder of 1 that we were looking for. So that's how we know we got the correct answer for the modular multiplicative inverse. All right, let's try another example. This one says, find the modular multiplicative inverse of 6 mod 21. So remember, we first have to check, does it even exist? So is the greatest common divisor between 6 and 21 equal to 1? Well, no, it is not, because the greatest common divisor would be 3 in this case. Or another way of saying that is that 3 is the largest number that goes into both 6 and 21. So since this number is not a 1, it means the modular multiplicative inverse doesn't even exist for this one. So for this one, we'll just say it does not exist. All right, let's try one more example. This one says, find the modular multiplicative inverse of 5 mod 11. So again, let's first check, is the greatest common divisor between 5 and 11 equal to 1? Yes, it is equal to 1, because 5 and 11 don't share any factors. So we know the modular multiplicative inverse exists. Now we just have to use this trick up here to actually find it. So for this example, 5 represents our a, and 11 represents our m. So using this trick up here, we're going to start with a value of k is equal to 1. If we plug that into this formula, here's what we get. M, so the m is 11, times 1 plus 1, that's 11 plus 1, which is 12. Is 12 divisible by 5? No, it is not. So then we'll move on to the next value of k, and we'll just keep working through these k values until we find a value that produces some number that is divisible by 5. So if we work through some different k values, we'll find that a k value of 4 produces a value of 45, and 45 is divisible by 5. So the modular multiplicative inverse of 5 mod 11 is just going to be 45 divided by 5, which is 9. So that's our final answer for this one. And again, if you want to double check that you're correct, just do a times x divided by m and check if you get a remainder of 1. So if we do a times x, so 5 times 9 divided by m, remember m is 11 in this case, we get 45 divided by 11, which is 4 with a remainder of 1. So we do indeed get a remainder of 1. So that's how we know that our answer is correct.